Hey, it's Gabriel. Today I'm going to show you some physics on rotational kinematics. This is a problem that I've already run into, and you might too. So let me give you an overview on rotational kinematics and then give you the problem. Here we go. Okay, so far you've studied translational motion or linear motion. Objects have been sliding, falling, or rising. And you've used these equations on the left, the linear equations, when acceleration has been constant. Now you're going to deal with problems where stuff is not only just sliding or falling, rising, but actually rotating also. All motion is some combination of translational and rotational motion. Okay, so let's make some connections between linear and angular measurements. For displacements, s equals radius times theta. For velocity, v equals r times omega. And for acceleration, a equals r times alpha. Now, all these equations, the first five that I mentioned, and now these three, all work assuming constant acceleration and that there's a fixed axis of rotation. Okay, so the problem states the tub of a washer goes into its spin-dry cycle starting from rest and reaching an angular speed of 3.3 revolutions per second in 7.4 seconds. At this point, the person doing the laundry opens the lid, and a safety switch turns off the washer. The tub slows to rest in 14.5 seconds. So the question is, through how many revolutions does the tub turn? Assume constant angular acceleration while it's starting and stopping. Okay, so in this problem, we need to find the revolutions when the tub was already spinning and also after it engages the switch and begins to slow down. So we're probably going to have to calculate that two separate ways, or just two separate times. And we also know that our answer is going to be in revolutions. And a last piece of information is that there is constant angular acceleration. So we know that we can go back to those list of linear equations and see that there's something that might fit what we need. And if we go down to the third one, I think we might have what we're looking for. Okay, some of the pieces of information that we can gather from the problem include the initial angular velocity, the first angular velocity, the second angular velocity, the first time, and the second time. So with all of these pieces of information, we should be able just to solve the problem. Okay, now just to solve the problem, we'll use the third rotational equation with final angular velocity, initial angular velocity, and time in order to find the displacement. And since we have all those things, we could just plug it in once for when the tub is first spinning, and another time for when the tub is starting to slow down and come to rest, and that will be in 36.135 revolutions. Okay, so you can see that that problem really wasn't that bad. But I guess if you're feeling brave, maybe you could move on to some torque and problems involving parallel axis theorem and inertia. But those will be for another day. Alright, thanks for watching my video. Hope you enjoyed it and I hope you've learned something. And I hope you like the music too, because I do.